Hello everyone, this is Phys103 and this is the last lesson on atomic structure, and this is actually the final goal in atomic structure. So we try to find structure in atoms. So in order to do so, we develop physical laws, and the end result is, well, this periodic table. So we finally have structure to how atoms behave, and it is simplified in the periodic table. So let's first start with the consequences of Pauli's exclusion principle. So it says that no two electrons can occupy the same quantum state. So with this principle, we can know how electrons are going to be arranged. And this we call as the electronic configuration. So now, using this principle, let's try to see how the electrons are configured in atoms. So for example, let's start with the simplest one, hydrogen. So hydrogen has one electron. So this one electron will always be in the ground state, which gives n equals 1, L equals 0, and ml equals 0, and ms equals plus minus 1/2. So let us introduce some notation here. So the electronic configuration for hydrogen will be 1s1. So this denotes the principal quantum number, and this denotes the shell. So it is located at shell S, and this is the number of electrons in that shell. So for hydrogen atom, we have one electron in the ground state, n equals 1, and it is at S shell with only one electron. So what about helium? For example, helium 2 electrons. So now these two electrons will still be in the ground state, L equals 0, ml equals 0, but now these two electrons will occupy the two spins, plus minus 1/2. So the electronic configuration for helium will be 1s2. So two electrons are sharing, if we want to visualize it. So you have two protons in the nucleus, and these two electrons will have spin up, one electron will have spin up and one will have spin down. Okay, so let's move one way up to the periodic table. Next is lithium. So lithium has 3 electrons. So if we try to look at the limits of n equals 1, so n equals 1 can only give L equals 0. So L equals 0 can only give ML equals 0, and ML equals 0 can only give MS of positive 1 half and MS of minus 1 half. So in other words, only 2 electrons can occupy the n equals 1 state. Are able to so what happens to the remaining electron? So lithium has 3 electrons, so we already know that 2 electrons will be in the n equals 1. So 2 electrons here. So the remaining electron will have the quantum state on n equals 2. Okay, so the next electron or the remaining electron for helium will be at n equals 2. So for n equals 2, we have L equals 0 and 1. And for L equals 0, we will be choosing L equals 0. It will only have ML equals 0, and it will only have MS, the spin, to be positive 1 half, not minus 1 half. Okay, so the electron configuration for lithium will be occupying all states in n equals 1. So 1, S2, all electrons will be, 2 electrons will be in n equals 1, and then it will, 1 electron will be in n equals 2. So 2, and then S dito for L, 2s1. So this is the electronic configuration for helium. So you could go on with multiple we could go on moving up on the periodic table, and in the next video we will be discussing the concept of screening. So this concept of screening is connected to the central field approximation, and this will explain why the valence electrons are important in determining the property of an element. So that's it for now.